Hello guys, so in this video we look at the first problem from Codeforces Round 948. The problem name is Little Nikita. So the problem description is as follows. There is a little boy named Nikita who was given some cubes as a present and he decides to build a tower out of them. So initially the tower did not have any cubes and in one move Nikita can either add exactly one cube on the top of the tower or remove exactly one cube from the top of the tower. So we have to answer whether it is possible after performing n moves that the resulting tower has exactly m cubes or not. So we have to answer yes if it is possible and no if it is not possible. So the constraints for n and m are between 1 and 100. So let's move to the explanation part now. So we are given two integers, n, which is the number of moves that we have to perform, and m, which is the number of cubes that the resulting tower should have after performing n moves. And also it is given that n and m have to be between 1 and 100. So let's break down this problem into a couple of cases. The first case being when the total number of moves are less than the number of cubes in the resulting tower. So we can clearly say that answer is no in this case. This case is simple and intuitive. The second case is when n, which is equals to m. The answer is always yes. So in each move you will just add one cube to the top of the tower, and in n moves you'll have m cubes, which is equals to n again. The answer is always yes in this case. When n is greater than m, let's consider an example where n is equals to 4 and m is equals to 2. So I'll denote A for addition of cube to the top of the tower and R for removal from the top of the tower. So let's see whether the answer is yes or no in this case. So in the first move, let's say we add a cube. In the second move, we again add a cube. So we already have a tower with 2 cubes, but we are still left with 2 moves. So let's say in the third move, we add again a cube to the top of the tower and we remove a cube. So this way the answer is yes. So in this case the total number of cubes are 2. Let's say you can also arrive at this scenario in a different way. So you first add a cube, then remove that cube, and then add and add. So in this case also you are able to have m cubes after these n operations. So the answer is yes in this case. So basically in whatever way you arrange these addition or removal operations on cubes, add and then remove, or you can do add, remove, add, or you can also do add and then remove, add. Whatever you perform these operations, the answer is always yes for this case. So how to build the logic for this problem? So one way can be for in the first m moves out of these n moves, we always put or add the cube to the top of the tower. Now after performing these m moves, we already have a intermediate tower with m cubes. So but there are still n minus m moves still left. So now we have to maintain that m cubes. So what m cubes in the result in the intermediate tower. So what we'll do is from these n minus m moves left, we'll first add a cube to the tower and then remove that same cube to maintain the tower to have m cubes. So basically we'll perform these addition and removal operations from these n minus m moves until they are exhausted. So let's say in these n minus m moves, you perform x addition operations or x put operations. So you should, whatever you add, you have to remove it. So you have to perform x removal operations as well, right? So the total number of operations that you perform is 2x for these n minus m moves. So basically x is some discrete move, right? So it should be an integer, So basically this n minus m should be a multiple of 2. For the answer to be valid. Okay, so summing up the let's consider an example. Let's say example is n is 6 and m is 3. So let's say you do first add and then you already have this tower with 3 cubes. Now you try to add another cube, you remove it and then you add. So see, this one add and one remove was present, but we added a cube, but there was no removal present because we had only 6 moves. So this is because n minus m was equals to 3, and this was not a multiple of 2. So this proves, this is how it validates the logic that we have derived. So now let's look into the code for this. We first take the input, which is t, and two integers n and m. So if n is less than m, or if n minus m is not a multiple of 2, then the answer is no, as we saw in the explanation. Otherwise the answer is yes. So this is pretty simple code, and the time complexity is order of t, because we are taking just order of 1 time per test case, and we are not using extra space, so space complexity is order of 1. So the solution link will be given in the description, and you can also take a look at the Java code for the same problem. See you all in the next video, and don't forget to subscribe to the channel if you like the video.